Hi, this is Max from Dynamixes. In this video, I will guide you through preparing your files to track a real-time project with your latest version of Performer, which is 2.7 version released in December 2018. After this tutorial, you should be ready to track and retarget to your 3D characters' facial expressions in real time, whether it is in Unity or Unreal. Before we start, you must make sure you have both the tracking profile and a retargeting profile ready with Performer. If this is not the case, please check our previous tutorials, creating a tracking profile and creating a retargeting profile. To prepare my profile for real-time tracking, I will have to create a new face entity set, transfer the links to the new face entity set, export my real-time retargeting profile, and export my 3D character in FBX format from Maya. First thing to know is that you cannot work with controllers that manage your 3D characters animation from Maya in Unity or Unreal, the most popular real-time engines. You'll have to convert it into a FBX format to import it in the 3D engine. If I import it to Unreal or Unity, I will not see my controllers, but only the skeleton, bones, and the Blendshapes they control. I previously created an entity set based on the controllers in Performer. I need to transfer the retargeting links from the controllers to my character's bones and Blendshapes. For this, I need to create a new face entity set that will take into account the joints and the Blendshapes. I'll go ahead and display joints in Maya. Go to Show, Joints in Maya. Even if you know that your full project will be real-time, always start to create a face entity set with controllers and edit the retargeting links with those controllers. Controllers take into account constraints and can impact multiple Blendshapes at the same time. Editing the links on the controllers first will facilitate the editing of bones and Blendshapes. So I'll create a new face entity set and I will name it real-time this time. I'll select the bones from the upper part of the skeleton in Maya and assign them to the upper solver. Then, I select the bones from the gaze, the bones from the lower part, and assign them accordingly. So, we have transferred all our joints. Now, I'll select the Blendshapes. Blendshapes from the upper part are mixed with Blendshapes from the lower part. You cannot select each shape separately. You will have to select the node and then reassign each Blendshape to the relevant solver in Performer. I'll start with the lower solver, as I know by experience that this is the solver with the most numerous Blendshapes. It is very important you name your Blendshapes properly. For example, I know that every shape entitled with the word eye belongs to the upper solver. If you have an extra topology that is dedicated to follow the facial expressions, it should be selected and added in the face entity set so it will follow faces movements. In this project, I will select eyebrows and eyelashes and assign them to the upper solver. Now, little warnings if you're using Unreal for your rendering in real time. Maya lets you use identical names for Blendshapes as long as they are in different nodes. However, when you will import your character in Unreal, Unreal will not take into account the parent node's name, but only the Blendshape names. It will then merge all the Blendshapes that have the identical name. And so, the rig in Unreal will appear with less Blendshapes. If you do not want those Blendshapes from different nodes to be merged, make sure to assign different names to them before creating the face entity set and exporting your character to Unreal. Go to the control panel on the right of your viewport in Maya, in the second tab entitled Attribute Editor. You will find two items, the Rotate and the Transform Attribute section, and the Joint Orient under the Joint section. You must ensure that the three values are set to 0 for all the joints you want to animate on your neutral pose before creating the new entity set and exporting your rig into FBX format. Otherwise, you'll find your rig rotations and joint orientation totally messed up. You should use the freeze transform under Modify Freeze Transformation and check the Joint Orient box. Be aware that you should do that before you add any skin. As soon as you have your bones linked to a skin, you cannot freeze on resetup. Another approach would be to export only the skeleton in another scene, freeze it, and then re-import it in the original scene. And since it has the same joints names, it will automatically replace them with the value set to 0. To understand why we need to reset all those values, you should know that our plugin for Unreal uses mathematics values to animate the character's bones based on their absolute orientation, which I could call their zero rotation. We will not have the same problem with Unity, but if you are planning to animate your character in Unreal, you must do such cleaning. I now have my two face entity sets, the initial one with my controllers, and the new one with my joints and Blendshapes that I call RT for real time. As for every entity set, you can always go back and modify elements, add or remove stuff. Now comes the time to transfer to the real-time entity set the retargeting links you previously created on the controller-based entity set. I look at the two last icons in my tools bar, the Create Link Scene and the Import Link Scene. The first icon, Create Link Scene, will create poses in my scene using animation keys. Basically, for every frame in my profile, the retargeting pose I previously created will appear on the timeline. It is a way to save all your poses in the same Maya file. So, I'll select my initial face entity set and click on the Create Link Scene. The system asks if you want to export your profile images in a dedicated folder, but I'll click on No as I do not want this right now. The links have been exported in my Maya scene. I now select my new face entity set called RT, which does not have any retargeting links yet, and click on the Import Link Scene. When I click on Import Link Scene, a new window will appear with three options. First, keep my previous state, which is not useful for a first import, since it will keep the unset solvers of the real-time entity set. Second, assign all poses for upper, lower, and gaze, which means it will take all the solvers into account, upper, gaze, and lower for each retargeting link. Third, reset all the poses and let me manually choose, which means we will save the retargeting links but choose the solvers later. I'll select the second option. Performer will read the poses in Maya frame by frame, and will transfer them to each frame on my real-time entity set in the same order. To sum up, Performer will use the poses to translate the links from your controllers in the first entity set to the bones and Blendshapes in the second entity set. A window pops up with the links imported message. Masked icons have been colored on my frames. I now want to check if my retargeting links with the Blendshapes and joints worked as well as the one with controllers. You should also delete all by type channels in your Maya scene so that the constraints will not drive the Blendshapes and joints anymore. If everything went well, the poses of my character should update in Maya. I have to build my retargeting profile by clicking on the Build My Profile and then solve my animation in the Session mode, just to check in Maya if everything moves accordingly. To do so, I will sync Performer timeline and Maya timeline and play the tracking in Performer. Now that my profile is built and I have checked my new links, I'm ready to export my real-time profile. To export the profile, I need to go under Profile and select Export Real-Time Profile. A new window pops up with Destination Folder selection. Several files will be created in the Destination folder. If you need to export your retargeting, please check the retargeting box. You might have to select several profiles if one actor's expression have been retargeted to multiple 3D characters. I will select directly the real-time profile and click on Export. I'm going to open the destination folder and watch my files getting created. Here's the folder Red Ghost that contains my reference picture, which will help me reposition the HMC on the actor in case it does not fit the tracking shape anymore. The DMC extension file is dedicated to the camera calibration. The file with the DAM3 extension is the one I will load in my enhanced version of Grabber. The file with the ESC extension is my face entity set with the Blendshapes and joint list. Finally, I'll disconnect Performer and show you how to export my 3D character in FBX format. I'll reset my Maya scene to the neutral expression so it's cleaner. To be cleaner, it's recommended to select only the joints and the meshes to export. Then, I'll go to the File menu and select Export Selection and export my 3D character in a new folder. I do not recommend to use the Export All option, as it will also export your controllers that you don't need in your real-time engine scene. Then select a name and select the FBX format to export your character. Don't forget in the FBX exportation window to check the animation box so that you be sure you're exporting your skinning, bones, and also the Blendshapes. You're done and ready to import your file in a real-time engine and live track. It is now time for you to select whether you want to work with Unity or Unreal. Check out our dedicated tutorials. Live animation using Unity or live animation using Unreal Engine.